Hello everyone, welcome back to my YouTube channel. I am Ranjit JS, a CSC student from Sri Venkateswara College of Engineering, Bengaluru, and currently I am studying in 4th semester. Now today in this video we are going to discuss two topics which are related to ADA, that is Analysis and Design of Algorithm. Let us see the topics. The topics are Insertion Sort and the Topological Sorting and its two methods. Firstly, let us see the insertion sort. Insertion sort is a simple sorting algorithm that works by iteratively inserting each element of an unsorted list into a correct position in a sorted portion of the list. It is a stable sorting algorithm, meaning that elements with equal value maintain their relative order in the sorted output. Let us see the algorithm. We are giving input as an array of 0 to n minus 1 elements of n elements, and the output we are getting is an array of a of 0 to n minus 1 sorted in increasing or non-decreasing order. And this is the algorithm for the insertion sort, which contains two loops, that is for loop and while loop. And in the for loop the condition is I is equals to 1 to n minus 1 and b is equals to a of I and j is equals to I minus 1, that is decremented by 1 with the value of I. And the while loop condition is j should be greater than or equal to 0 and a of j should be greater than b. Then only the code which is present in the while loop will be executed. If this condition satisfies, then a of j plus 1 is set to a of j and j is decremented by 1. And if the condition is false, then the code which is present out of the while loop will be executed. That is a of j plus 1 is set to v. Until the condition falls in the while loop will be repeatedly executing. And here are the steps to perform insertion sort. Start with the first element as the sorted region. Take the next element from the unsorted region and compare it with the element in the sorted region. Insert the element into sorted region at the correct position. Repeat the process until the unsorted region is empty. The sorted region now contains the entire input list. Now let us take an example and solve according to the algorithm. And the example is array of 89, 45, 68, 90, 29, 34, 17. We should sort this in an increasing order. Now let us see the first iteration where I is equals to 1, b is equals to 45 and j is equals to I minus 1, that is 1 minus 1, that is 0. And while j is greater than or equal to 0 where j is equals to 0 and 89 is greater than or 45 where 89 is equals to a of j and 45 is equals to b. Therefore the condition satisfies, that is true. Therefore, a of j plus 1 is equals to a of j. That is, a of 1 is equals to 89. That means a of 1 value is set to 89 and j is decremented by 1. That is 0 minus 1 is equals to minus 1. Now the j value is minus 1. Again, while j is greater than or equal to 0, that is minus 1 is greater than or equal to 0, it's false because it is less than or equal less than 0. Therefore, it comes out of the loop and execute the code which is present out of the loop. That is, a of j plus 1 is equals to b, where a of j plus 1 is equals to a of 0 is equals to 45, where j is equals to minus 1 and minus 1 plus 1 is equal to 0. Now the sorted array is, that is 85. Now the sorted array is 45, 89, 68, 90, 29, 34, 17, where 89 and 45 are exchanged. Now let us see the second iteration where I is equals to 2, v is equals to 68 and j is equals to 1. While 1, that is j is greater than or equal to 0 and 89 is greater than 68, where 89 is equals to a of j and 68 is equals to b, the condition satisfies, it is true. Therefore a of j plus 1 is equals to a of j, where a of j plus 1 is equals to a of 2 is equals to 89. And the j is decremented by 1, that is j is equals to 1 minus 1 is equals to 0. Then again the while loop is executed. While 0 is greater than or equal to 0, that is true, and 45 is greater than or equal to 68, but it is false. Therefore it comes out of the loop and execute the code which is present out of the loop, that is a of j plus 1 is equals to b, that is a of 1 is equals to 68. Now the sorted array is 45, 68, 89, 90, 29, 34, 17. Now the 68 and 89 are exchanged. Now let us see the third iteration where I is equals to 3, b is equals to 90 and j is equals to 2. While j is greater than or equal to 0 and 89 is greater than 90. Where 2 is greater than or equal to 0, that is true, but 89 is not greater than 90, that is false. Therefore it comes out of the loop and execute the a of j plus 1 is equals to v, code. That is a of 3 is equals to 90, and there is no change in the sorted because a of 3 is already 90. Therefore, the sorted array is 45, 68, 89, 90, and the unsorted array is 29, 34, 17. Now let us see the fourth iteration where I is equals to 4 and b is equals to 29, j is equals to 3. While 3 is greater than or equal to 0, true, and 90 is greater than 29, that is true. Therefore, a of j plus 1 is equals to a of j, that is a of 4 is equals to 90, and j is decremented by 1, that is 3 minus 1 is equals to 2. While 2 is greater than or equal to 0 and 89 is greater than 29, a of j now is a of 2. A of 2 value is 89. Both conditions are satisfied, therefore true. A of j plus 1 is equals to a of j, that is a of 3 is equals to 89, and j is decremented by 1. While 1 is greater than or equal to 0 and 68 is greater than 29, both conditions satisfies true. A of j plus 1 is equals to a of j, that is a of 2 is equals to 68, and j is decremented again by 1. 1 minus 1 is equal to 0. Now while j, that is 0, is greater than or equal to 0, and a of j, that is 45, is greater than 29, true. A of j plus 1 is equals to a of j, that is a of 1 is equals to 45, and the j is decremented again by 1, that is 0 minus 1 is equals to minus 1. While minus 1 is greater than or equal to 0, false, because minus 1 is less than 0. Therefore it comes out of the loop and execute the a of j plus 1 code part, that is a of 1 is equals to 29. Now the sorted array is 29, 45, 68, 89, 90, and the unsorted array is 34, 17. Now the 29 is placed in first position, that is 0th position. Now let us see the fifth iteration where I is equals to 5 and v is equals to 34, j is equals to 4. While 4 is greater than or equal to 0 and 90 is greater than 34, true. Therefore a of 5 is equals to 90 and j is decremented by 1, that is 3. While 3 is greater than or equal to 0 and 89 is greater than 34, both conditions satisfies, therefore true. Therefore a of j plus 1 is equal to a of j, that is a of 4 is equals to 89, j is equals to 3 minus 2. While 2 is greater than or equal to 0 and 68 is greater than 34, where 68 is equals to a of 2 value, both conditions satisfies, true. Therefore a of j plus 1 is equals to a of j, that is a of 3 is equals to 68, and j is decremented by 1, that is 2 minus 1 is equals to 1. 1 is greater than or equal to 0 and 45 is greater than 34, true. A of j plus 1 is equal to a of j, that is a of 2 is equal to 45, and the j is again decremented by 1. Therefore j is equals to 1 minus 1 is equals to 0. While 0 is greater than or equal to 0 and 29 is greater than 34, false. 29 is not greater than 34. Therefore it comes out of the loop and execute the code part which is present outside the while loop, that is a of j plus 1 is equals to b. Now the a of 1 is equals to 34. Therefore the sorted array is 29, 34, 45, 68, 89, 90, and 17. Now the 34 is placed in the second position, that is 0 and first position. Now let us see the sixth iteration where I is equals to 6 and v is equals to 17 and j is equals to 5, while j is greater than or equal to 0, that is 5 is greater than or equal to 0 and 90 greater than 17, true. Therefore a of 6 is equals to 90 and j is decremented by 1, that is 5 minus 1 is equals to 4. While 4 is greater than or equal to 0 and 89 is greater than 17, both conditions satisfies, true. Therefore a of j plus 1 is equals to a of j, that is a of 5 is equals to 89, and j is decremented by 1, that is after decrementing the j value becomes 3. Now while j is greater than or equal to 0, that is 3 is greater than or equal to 0 and 68 is greater than 17, both the conditions are satisfied, true. Therefore a of j plus 1 is equal to a of j, that is a of 4 is equals to 68 and j is decremented by 1. Now while here now the j value is 2, while j is greater than or equal to 0, that is 2 is greater than or equal to 0 and 45 is greater than 17, both conditions satisfies, true. Therefore a of j plus 1 is equal to a of j, that is a of 3 is equal to 45. J is decremented by 1, that is 2 minus 1 is equal to 1. Now again now the j value is 1, while 1 is greater than or equal to 0 and a of j, that is 35, is greater than 17, true. Therefore a of 2 becomes 34 and j is decremented by 1. While 0 is greater than or equal to 0 and 29 is greater than 17, both conditions satisfies, true. Therefore a of 1 is equals to 29, j is equals to 0 minus 1 and minus 1. While minus 1 is greater than or equal to 0, the condition false, it is not greater than or equal to 0, it is less than or equal to 0. Now the while loop is terminated and the code which is present outside the while loop will be executed. That is a of j plus 1 is equals to b, where a of j plus 1 is equals to a of 0 is equals to b is equals to 17. Now the 0th position is occupied by the 17. Therefore, the sorted array is 17, 29, 34, 45, 68, 89, 90. Therefore, the finally sorted array is 17, 29, 34, 45, 68, 89, 90. Like this, with the help of the algorithm, we can make the insertion sort. Let us see the insertion sort efficiency. Insertion sort is a simple sorting algorithm that builds the final sorted array one time at a time. Its efficiency is based on its ability to efficiently sort small arrays or partially sorted arrays. Insertion sort has a time complexity of big O of n square in the worst case scenario. Now let us see the best case scenario for insertion sort. The best case time complexity for insertion sort is big O of n when the array is already sorted. In this scenario, the algorithm only compares each element with its adjacent elements and moves on to the next element. This makes insertion sort highly efficient when dealing with nearly sorted arrays. Now let us see the summary of this insertion sort. Insertion sort is a simple and efficient algorithm for small datasets or partially sorted arrays. While it may not be the most efficient for large datasets, it has its advantages in specific scenarios. Understanding the efficiency and limitations of insertion sort can help in choosing the right sorting algorithm for different tasks. Now let us move on to the another topic, that is topological sorting. That is the introduction. Topological sorting is a method used to order the vertices of a directed acyclic graph (DAG) in a linear order. It ensures that for every directed edge from vertex u to vertex v, u comes before v in the ordering. This ordering is useful in scheduling tasks, resolving dependencies, and optimizing operations. Now let us understand what is DAGs, that is directed acyclic graphs. A directed acyclic graph is a graph with directed edges and no cycles. In a DAG, nodes are arranged in a way that there is a consistent direction of dependencies between nodes. Topological sorting is only applicable to DAGs as it requires a linear ordering of nodes without any cycles. Now let us see the first method, that is depth first search DFS algorithm in the topological sorting. DFS is a recursive algorithm that explores as far as possible along each branch before backtracking. It uses a stack to keep track of nodes to visit and mark each visited node to avoid revisiting them. DFS is commonly used in graph traversal topological sorting and finding connected components in a graph. Now let us take a small example and get the topological order of this by using a DFS method. In this example, I didn't use a stack. Instead of stack, I clearly explained in this table only. The table contains three columns, that is select vertex, adjacent vertex, and the popped vertex. Now first of all, let us take an starting vertex A and put it in the table, and the vertex A contains an adjacent vertex, that is B, because A is directing towards B. Let us go on, but here A is towards C also, but let us go in an alphabetical order. Therefore, adjacent vertex of A is B. Put it in the table in the adjacent vertex. But here A is containing the out degree. Therefore, we should not pop any elements. We should only pop the vertexes which does not contain any out degree. Now put it the adjacent vertex into the select vertex and find the adjacent vertex for B. For B, the adjacent vertex is E. Put it in the adjacent vertex. Now for B also there is an out degree. Therefore, we should not pop the B. Now put the adjacent vertex E into the select vertex, but here the select vertex E does not have any out degree and does not have adjacent vertices. Therefore, pop it out and write down in the popped vertex column. Now E is popped, leave the E, and the vertex which is before E is B. Now take this B here. Now the adjacent vertex for B is G. Put it in the adjacent vertex, and B contains two out degrees, therefore we should not pop B. and put the adjacent vertex G into the select vertex and find the adjacent vertex for G. For G, the adjacent vertex is F, and put it in the adjacent vertex. But for G, there is an 1 out degree, therefore we should not pop the G. And put the adjacent vertex F into the select vertex and find out the adjacent vertex. For F, there is no out degree because all three are only in degrees. Therefore, pop that F and put it in the popped vertex column. Now F is popped. Remove the F and the vertex which is before the F is G. Put it in the select vertex and find the adjacent vertex for G. For G, the adjacent vertex is there is no adjacent vertex because already F is popped out and E is popped out. Therefore, as there is no another out degree, just pop it and write down in the popped vertex table. That is G in the popped vertex table. Now G is popped out, F is popped out. Next, the remaining is B. Put it in the select vertex table. Now let us find the adjacent vertex for B. For B, adjacent vertex is G and E, and also the G and E are already popped out. Therefore, again pop out that B because there is no out degree for the pop out that B and write in the popped vertex column. Now B is popped, G is popped, F is popped, G is popped, B is popped, E is popped, and again B is popped. The remaining is A. Put it in the select vertex A. Let us find the adjacent vertex for A. For A, the adjacent vertex is C. Put it in the adjacent vertex, and A has out degrees, that is C. Therefore, we should not pop out. Now put the adjacent vertex C into the select vertex. Now for select vertex, the adjacent vertex is F, but F is already popped out. Therefore, there is no further adjacent vertexes. That is, there is no further out degrees for C. Therefore, pop out that C and put it in the popped vertex. Remove this C and just before that C, which alphabet is there, take that as select vertex. If that is not popped out, A is not popped out, then select A, find the adjacent vertex for A. There is no adjacent vertex for A because there are only two C and B, they are already popped out. Therefore, as there is no out degree, then pop out that A. Now A is popped out. Now the remaining vertex is D. Put it in the select vertex and find the adjacent vertexes. There are 5 adjacent vertices A, B, G, F, C, but all these 5 are already popped out. Therefore, remaining D does not have any out degrees. Therefore, pop it out. Now, the topological sort is go from down to top of the popped vertex column. That is D, A, C, B, G, F, E. Therefore, the topological sort is D, A, C, B, G, F, E. In this order, the topological sort order will be getting if we solve by using DFS method. Now let us see the another method, that is source removal method for topological sorting. In this source removal method, we repeatedly remove nodes with no incoming edges for the graph. The removed nodes from the topological order of the graph. This method is efficient for topologically sorting a DAG and can be implemented in linear time complexity. Now let us take the same example and get the topological order by using a source removal method. Step 1. Remove D because D does not have any in degrees. And after removing D, we will get the graph like this and put that removed element D into the topological order. Let us see the step 2. Step 2. Remove A because A does not have any in degrees. Because A does not have any in degrees, and after removing A, we will get the graph like this and put that A into the topological order. Now let us see the step 3. In the step 3, we will remove B because B does not have any in degrees and C also does not have any in degrees, but we will go in the alphabetical order. Therefore, remove B. After removing B, we will get the graph like this and put that removed B into the topological order. We will get D, A, B. Now let us see the step 4. In the step 4, we will be removing C. And after removing C, the graph will be appearing like this F, G, E. And put that removed C into the topological order D, A, B, C. Let us see the step 5. In the step 5, we will be removing G because G does not have any in degrees. After removing G, we will be getting graph like this FE and put that G in the topological order. Now let us see the step 6. In the step 6, we will be removing E because in the alphabetical order E comes before and later F comes. Then the graph will be appearing like this and put that E into the topological order. We will get D, A, B, C, G, E. And after that remove this F and put into the topological order, we will be getting D, A, B, C, G, E, F. Like this we can get the topological order using source removal method. Thank you for watching the video.